let's find the shape factor of the rectangular section. Okay, we are going to derive the shape factor of a rectangular section. So shape factor is the same as the plastic capacity you divide by the section modulus. So here is the structure, the rectangular bite. From the top to the bottom we have D, and then from the top to the equal area axis, of which it is D over 2, and then this, the lower part, the tension sector is D over 2 also. So we have now Y1 being the COG of the compression, but that's from this point here to this point. This is Y1. Then from the top to the COG of the compression vector is Y2, Y1 also. So, and then we have for the tension part being Y2, same case to this point here, Y2. So we are going to find the plastic modulus of this rectangular sector. So plastic modulus. So plastic modulus is the same as area of the compression, then you multiply by Y1 plus area of tension part, you multiply by Y2. So it will be the area of the compression region will be BD, of which we have B is the same as our B. So our B is B, and then our height is the same as D over 2. You divide by 2, because we have 2 parts for the compression region. So D over 2 is the same as multiply by 1 over 2, so D over 4. So D over 4 is our H. So BD, our area of the compression back, is equals to P, you multiply by D over 4. So it's the same as BD over 4. This for the area of the compression region, you multiply by the COG of the compression area. Then we have also for the tension area, we have our B being P, then our height is equals to D over 2, you divide by 2 also is the same as D over 4. So we'll have to add the two, this one and this one. D over 4, you add D over 4. LCM is 4. D plus D equals to 2D over 4. So before we add this one and this one, we'll have to substitute the same formula here. So we have the areas of the compression and the area of the tension part. So we'll have to multiply each area by the Y1. So in this formula, we had area of the compression area, and then we multiply by Y1. So our Y1 here, Y1 is the same as D over 2, you divide by 2, for which it is D over 4. And then Y2, the same case, D over 2 you divide by 2, equals D over 4. So we'll have to multiply now the area of the compression part, multiply by the Y1 and Y2. The same case for the tension part. So we'll have to do this. So the area of the compression area, total area of the rectangular part is same as BD, is the area total. So, but we have our equal area axis at D over 2. So the area of the upper part will be BD, you divide by 2, because the equal area axis divides the rectangular section into 2 equal parts. So BD over 2 is the area of each each part. So we have BD divided by 2 is the area of compression. BD over 2 is the area of tension pipe. So we multiply now by Y1 and Y2. Y1 was D over 4. Y2 was D over 4. So set B was area of compression multiplied by Y1 plus area of tension multiplied by Y2 in bracket. So we'll have to substitute the equation here for us to get the plastic modulus. So area of the compression bath is BD over 2. You multiply by Y1, which is D over 4, plus BD over 2. Okay, so you multiply BD over 2, you multiply by D over 4 also. So this one will be BD squared over 8 plus BD squared divided over 8. Then our LCM is 8. So BD squared plus BD squared. So BD squared over 8, 2BD squared over 8 by 2, 1 by 2, 4. Equals BD squared over 4. This is now our set B. So set B is equals to BD squared over 4. So after getting the plastic modulus, we'll have to find also the section modulus. So section modulus is equals to I over Y bar, of which this I is the second area of moment. And then Y is the neutral axis. So we'll have to, so I for the rectangular section, is the same as I is equals to BD cubed over 12. So BD cubed over 12 is the equal the second moment of area for the rectangular section, but our Y bar is D over 2. That's the equal area axis. So D over 2 is our equal area axis. So you say for us to get the section modulus, we substitute this equation here. So we'll have BD cubed over 12 divided by D over 2 equals BD cubed over 12 times 2 over D. So by D1 by D squared by 2, 1 by 2, 6 equals to PD squared over 6. This is our section modulus. So after getting the section modulus, which is BD squared over 6, and we have already the plastic modulus being BD squared over 4. So shape factor here, we had the formula for finding the shape factor for the rectangular section is the plastic modulus you divide by the section modulus, which is set B you divide by Z. So set B over Z is the shape factor. So we substitute the equation there. So we have our set B being BD squared over 4. So it's equals to BD squared over 4 you divide by Z, which is the section modulus which we got here to be BD squared over 6. So it's equal to BD squared over 4 you multiply by 6 over BD squared. So BD squared cos BD squared cos by 2 by 2 3. So 3 over 2 equals to 1.5. So shape factor of the rectangular section is the same as 1.5. So, and you have to note that the shape factor must always be more than unity. So the shape factor is okay for the rectangular section. So make sure you subscribe to our channel. Thank you for watching.